Yes, good morning. Kindly join. Measures of averages, or we can use the term called as central tendency. The session is a very, very important session. You have to give a keen concentration on today's session. But don't get yourself deviated. Measures of averages, or the term which you can use it here is central tendency. Okay. You have calculated your percentage marks in your 10th or 12th, right? What you have done there? What you have done there? Probably you're getting five subject marks: 80, 85, 90, 95, 70. How you calculate the percentage marks? How you do it? You add everything, right? Am I right? You add everything, then you divide by 5. Why 5? Because it's for 5 subjects. Then you multiply by 100. If you're going to do it in percentage, you will multiply by 100. Have you ever thought why you're adding all this and dividing by 5? We don't know, ma'am. Our teacher told to do all this and we're doing it. That's it. Have you ever wondered why you're doing all this? Okay. If I asked you find average, example, mean of marks, what you'll do? What you'll do? If I'm asking you to find the mean of your marks, what you'll do? Average, what you'll do? Summation x by n is the formula you might have studied in your school. So what do you do actually here? X is, this is one x, name it as x1. This is one x, name it as x2. This is one x, name it as x3, x4 and x5. Summation x, which means you have to add all the x values, which is x1 plus x2 plus x3 plus x4 plus x5 divided by number of x's. 5. What you did here, you took the first subject mark, second subject, third subject, fourth subject, fifth subject, divide by number of subjects. Here we are naming this 80 as subject 1 marks, naming this 85 as subject 2 marks. But here what we are doing is a general concept where we are asking to take the average, you add everything and divide by n. This is the application of average, where this is the direct concept of average. So what you are doing here, you are adding all the x value and dividing by 5. So if you add all the x values, 80 plus 85 plus 90 plus 95 plus 70 divided by 5 will be your average x. Here you add everything. You need not worry about converting to 100, because why we convert to 100 is we want to go in percentage. That's why we convert to 100. So what happens over here? What is your value? This is your average. I don't want the value. I want the term. How you define this one as average marks. Have you ever wondered why you're multiplying this by 100? Why you're multiplying this by 100? Or have you ever wondered, probably this 80 marks may be out of 100, this 85 may be out of 100, this 90 may be out of 100, 95 is also maybe out of 100, whereas the 70 is out of 80. What you have to do then? You have to add all these, okay, but you have to give weightage for this one also. See, if everything is divided by 100, then it's fine. But here it is out of 80 you're working. This concept will not work out. So what you have done? See, you might have done all this. What you have done? See, this is for 100. This is for 100. This is for 100. This is for 100. But this is not for 100. So what you do is, this you make it 100. How you make this as 100? You add 20 here. No, you should not do addition and all. How you make this as 100? You divide by 100 and multiply by 100. So obviously here also you divide by 100 and multiply by 100, so that the 70 is not getting affected. Okay. So what we do is, this base will be taken to 100, and if you, for the whole thing, if you multiply by 100, this will be a percentage marks. My intention is not to discuss on percentage marks. My intention is to discuss on the average marks. So when we use the term average, make yourself that instead of representing 5 different marks, what I'm doing here is, all I'm taking as single value. That's a beautiful concept, single value. So your marks, whether you are getting this rank 1 or rank 2 or rank 3, whatever it is based on your percentage marks, only not your individual subject marks. Am I right? Am I right? So this single value is what you call as the representative. I want to highlight this word, representative. You need not copy each and everything from the board. Okay, not necessary also. I request you to make a note of this word. So what are the terms we are using so far? One is average. One is, yes, you're on. One is average. Another word we started with saying is nothing but representative. Can take a list of all these wordings. So average, representative. Yeah, like to take over. So instead of me representing myself, I got 80, 85, 90, 95 and 70 so on. I'm going to represent as a single value, and that single value is what we call as the average in general. But please remember, when we say average, okay, we are not going to talk only with respect to mean alone. Instead, we'll talk with respect to median. Okay. Instead, we'll talk with respect to mode also. Okay. Median and mode also. When we use the term mean, when we use the term median, and when we use the term mode. For each and every situation, the thing is different. The average is different. We are not going to use all the terms everywhere. Okay. It's different. Likewise, when we go for using mean, we have three types of mean. Anybody can join? We have three types of mean. One is arithmetic mean, one is geometric mean, and one is harmonic. Okay, we have three types of mean. So whenever you find the term called as average, we have to come across 1, 2, 3, 4, 5 words. We have to check which one is applicable where. Okay, so remember, average is not just mean alone, and it's not just arithmetic mean alone. You have to consider either it may be arithmetic mean, either it may be geometric mean, or either it may be harmonic mean. Why not? We may be discussing on median. Why not? We may be discussing on modes. Is it okay? So we'll be discussing on all this before going for directly to the problems. Let me go for three types of problem. Yes, you can join with me here. We'll go for three types of problem. First problem is called as individual observation. First problem is what you call as individual observation category. Okay. Second is discrete series. And third is continuous series. We have already discussed with classifications, right? What are the four classifications you know? What are the four classifications? Yes, please. What are the four classifications you know? Yeah, please join. We can turn to the pages and refer. No issues. What are the four classifications we have, Pa? Yes, we can find it in statistical interpretation of data, not in this topic. Yes. Qualitative classification. Okay. Quantitative classification. Yeah. Qualitative classification. Yeah, please. Chronological classification and geographical classification. Okay. And remember, we did this grouping qualitative, chronological, and geographical as one group, and this one as other group. And while we were discussing this, the earlier topic, statistical interpretation of data, we were saying that when you go for graphical representation, graph is done only for quantitative. You remember? When we use a graph, we have scale, x-axis, we have scale, y-axis. Then only we use the graph, which means it should be quantitative. But when we talk about bar diagrams, pie diagrams, other than what multiple diagrams and whatever the different diagrams you have seen, all these will be done only for qualitative, chronological, or geographical. When we talk about two dimension or two axis, one is x axis and one is y axis, which means here we'll be representing the number of items. Am I right? Number of students, number of workers, number of number of, which is number of is nothing but frequency. The x axis will be representing the height, weight, mass, wages, All these will be represented in x-axis, which is nothing but quantitative classification. But when we talk about qualitative, geographical, or chronological, here we'll draw bars where for the year 2010 we draw a bar. It's nothing but chronological, date-wise, year-wise. Okay. For 2020 we draw another bar. For 2030 we draw another bar. And this you cannot call, or you should not call this x-axis and y-axis. We call this as horizontal line and vertical line. So this is what you call here as frequency line, the vertical line, and this is one with respect to the chronological values. When you go for pie diagram, the same thing happens. Okay, this is representing materials, this is representing labor, this is representing overheads. Okay, this is representing profit, or this is representing profit, this is representing sales, advertisement. All these are qualitative classification. Please try to recall all the concepts. Okay, but when we are discussing quantitative in nature, then only we can go for further analysis. So the topic we are going to discuss today, that is measures of averages and dispersion, is completely meant for quantitative only, is not applicable for qualitative, chronological, or geography. It's applicable only for quantitative classification. So I have taken three type of problems, and three types are there. Individual observation is one, discrete is one, and continuous is one. And for each and everything, we are going to discuss three problems. Okay. For this is one problem, this is one problem, and this is one problem, where I'll be covering all the concepts here. Our main focus is to go for definition, the formulae. So we'll go this order now. What do you mean actually by the definition? What is mean? What is median? What is mode? Then we'll go for formulae. So whenever we take a heading, whenever we take an average, please try to understand in this angle. Definition, formulae, and a problem. Okay. This problem for individual separately, for discrete separately, and continuous separately. Okay. Sometimes formulae, we'll be having some 2 or 3 formulas. We have to understand then and then. Okay. So we'll go for first 3 problems. In your Singer material, can you identify the 3 problems I have noted with the heading type 1, type 1 problem in page 2.4? Just scroll a little bit. Almost you have to go for 50% of the topic. After that, you will find type 2 problem, which will have the heading discrete series. Can you just let me know the page number? Yeah, 2.14. Yeah. This identification of the problem is the very first thing you have to know. Then only you'll understand the formula. Okay, this is type 2 problem. Shall I take over? Page number for type 3 problem. Can you find the heading as continuous frequency distribution? In this problem, you will get class interval step. Okay. This is type 3 problem. Okay. Yeah, please join. Please try to understand what's the difference between type 1, type 2, and type 3. In your question paper, it will not be never be mentioned as individual or discrete or continuous. You have to understand. The first one, quite simple. From the heading itself, we can understand it's of individual observation. What do you mean by observation? Okay. Do you remember how the statistics is done? First, we'll go for collection of data, am I right? Then we'll go for classification. Then we'll go for representation, tabulation, graphical, and all. Then we'll go for analyzing, and then we go for interpretation. This is how it is being done usually. The very first step, collection of data, the data which you've collected is by observation. What do you mean by observation? You are doing a survey and you ask the 10 people to come. Okay, that may be from your personal relation or any friends of yours, anything it can be. You're collecting 10 people's height, which means what? You're observing. How you observe? How you check the height? How you check the weight of a person? Yeah, please. Maybe height check பண்ணுவீங்க. You take a scale, you take a pencil, measure it, or you have that equipment which suggests the height. How you check the weight for 10 people? You have a weighing machine. and you ask them to stand over there, remove the chappal, stand over there. This is how you check your weight, right? And you know the difference between mass and weight, right? Okay. You know the difference between mass and weight? Actually, it's your body mass because in you're in Earth, it's a weight because of the gravitational effect. If you go to Moon and other planets or other satellites, your weight will be differing. Okay, weight is something because of the gravitational effect. It shows the number. That's a weight. Actually, we are checking our weight only. Our body mass will be different. Okay. So how you check this weight? You just take the weighing machine and it displays the number. It shows your weight. This is what you call as observation. Okay. I'm taking four people. One person, one is showing 3 kgs weight. Okay, weaker, newborn baby. Okay. Another person showing 6 kgs weight. Again, born and what some 6 months, 8 months old. Another person weighing 24 kgs weight. Okay. Another person weighing 48 kgs weight. How we checked all these? What's the first step? You collected the data. What would be the second step actually? You have to classify. How are you going to classify? How are you going to classify this value? இருக்கதே 4 பேரு. Why I need to go for classification now? I need not classify. I will skip this step. You want to represent it using a table? Not necessary at all. See, actually, if you're classifying means you have to give like this. Person's weight and number of persons. This is how you do, right? You go for frequency distribution, drawing tally marks and bars and all. How many are in 6? How many are in 3? How many are in 24? How many are in 48? What do? You draw a tally bar and you say 1, 1, 1, 1. Totally 4 people, right? But this is all not necessary because there is actually only a few observations. You may not go for doing so much of things. So what you can do here is you can comfortably skip this test and skip this one. Directly you can go for analyzing. Now let me ask you. This is just instead of writing this as weight, I take it as marks. Okay, I take it as marks. Marks of 4 students. Okay, tell me which student has secured the best mark. 48. Fourth student. Okay, who's got 3 marks? Failed. 6 marks? Failed. 24? Failed. The only student passed? Fourth student. See, I can give any number. This is what you call as interpretation. Analyzing is something where we see the data, we write in this way, we say this is the minimum value, this is the maximum value, this is what you call as analyzing. Interpretation is, I put all different questions. I want to know who's the topper in the class, the student who got 48. I want to know how many students failed. How many students failed? 3 students failed. I want to know how many students secured about 20, 24 and 48. I want to know how many students got single digit mark, 3 and 6. I want to know how many got above 15. Nobody. See, I can put so many questions and with one single table and one single data, I can get all the results. This is what you call as interpretation. Okay, this is what you call as interpretation. But this is only just 4 observations I have. What is the n value? N is equal to 4, right? 3, 6, 24 and 40. Only 4 values I have where I'm not going to worry about classifying the data, or representing the data. That I can go for analyzing the data where I can find the mean value, median value, mode value and all the values. Now go for this table. Go for this type of problem, type 1 problem. Try to understand the heading. Individual observation. Which means what? We have only very few. You can please make a note over here. Over here is not in your paper itself. You need not copy from the board directly. In your material itself, you just have some writings. Very few observation. Few observation means in fact, we need not go for classification. So classification is not necessary. Okay. Tabulation or representation is not necessary. Okay. Directly you can go for analyzing. Please try to understand. It's very important. So what are the values we have? 3, 6, 48, 24. Only 4 values. So you need not go for classifying. You need not go for representing. Directly you go for analyzing. Analyzing means what? We are going to find mean value, median value, mode value. Probably It's because we are preparing for our exams, we are going to find all the values, but in your exam, it will be asked, some code words will be given, and depending on that understanding, you have to find mean, median, mode, or whatever else. You cannot go and find everything. Shall I go for type 2 problem? Same observations, you are doing it. Please try to understand. Please join with me. Same observations, you are doing it. But it's not just 4 or 5 persons. For how many persons we have done? So you're going to collect marks and the number of students you have secured this much marks. What do you understand from this table? Okay, if I ask you, how many students have got 19 marks? How many students? 30. So this is what the table says, right? How many students have got highest repetition? Which means what? 100. Yeah, see? See, first I went from here. Student who got 19 marks. You said 30. I'm saying, see, how many will be getting centum in maths or accounts? Only few. How many have failed? Only few. The average marks, right, like 60 to 70 or 70 to 80, this, so many will be repeating between these marks. So this 13 marks is highly scored by many students. Yes. It's not just 4 or 5 observation. If it's just 4 or 5 observation, I can go for type 1 data. It's not just 4 or 5 observation. What happens here? We have so many number of students. Can I get the value of this one? That is how many number of students in this observation? Yes, please, can I get the value? 581. So totally, I have just gone for collecting the data for 581 students. Okay. After collecting the data, I have gone for classification. This is the order, right? Am I right? Are you all here? First, what we did? We collected all the values. I conducted a test. Okay, this is what's the heading here is marks and number of students. I conducted a test for how many marks? Maybe for 20 marks. How many are secured less than 10? No data is given for less than 10. So how many are secured less than 10? 0. Okay, how many are secured exactly 20? No students. 0. How many are secured between 10 to 19? We have totally 581 students. So what I have done first, I just conducted the test. I collected your marks by correcting the paper. Then second step, I go for classifying. What classification is this one? Quantitative classification, because I'm giving the weightage for the marks 10, 11, 12 and so on. Then what happens next one? We have to go for representation. Representation is, you can either go diagrammatically, either you can go tabulated. What type of a representation is this one? We have tabulated. Then what is the first step? We have to analyze, which means we find the average, mean, median, mode of errors. How it differs from type 1 and type 2? Type 1, it was just only 4 values. I need not go for classification. I need not go for representation. But what happens here? We have totally 581 values where without classification or without representation, you cannot go for further analysis. So it is needed over there once asked in the exam. So it's needed over here. Likewise, you go for type 3. Let me finish off type 3 also. We'll go for type 3. What it is called as continuous frequency distribution. See, in the earlier problem, I conducted a test for my students where it is only for 20 marks. And my classification is a quantitative classification where I can start with 10, then 11, 12, goes on up to 19 because there was no students below 10 marks and no student exactly like 20 marks. So I went for classifying as 10, 11, 12, 13, 14, 15, so on. But what happened here now in third situation is I conducted a test, a complete syllabus test where it was for 100 marks. So you just remember, if I tabulate as 1, 2, 3, 4, it will be a very big table. And probably I'll not find space or screen to present all everything in one single table, right? So what I'm doing here is I'm making it as class intervals. So this is continuous series is nothing but we'll have class intervals. So why do you collect? You collect as individual values. But because you have, how many values are here? Can you get the value? How many values here? 90. It's because I have 90 values and also the marks, total marks is 100 marks. I cannot present in type 1 manner, right? Type 1 manner is when suitable. Only the n, the small n size. Okay, it's very, very small. 4 or 5 or maximum 7 or 8. If I go for type 2, if it is for discrete values, see 10, 11, this is what you call as discrete, where you have definite values. What do you mean by discrete? You have definite values. What do you mean by definite? Okay. See, type 2 problem. I'm asking you how many students got 17 marks? How many students? From the table, you can clearly say 75 students got 17 marks. It's the same question I'm asking you. See, type 3 problem. How many students got 17 marks? You cannot exactly say. Why? This class intervals contain from 11 to 20. It has 17 also. The number of students, there is 7 number of students secured in this category. You cannot say 11 mark or 20 mark or 17 mark or 18 mark. Which means what? You will not have no definiteness. No definiteness. But most of the category, what it has is when it goes for many lengthy values, then obviously we go for choosing type 3 only. But very best and suitable method is type 2. So always will not be worried about type 1, right? Because it's very rare to have 4 or 5 observations. Type 2 is more suitable in most of the cases. But then sometimes practically when we go for large amount of value like having 100 marks or 1000 marks or whatever it is, then it's very suitable to go for type 3 values. Is it okay? So what's the difference between type 2 and type 3? Here we'll define in terms of class intervals or class limits of class boundaries. No definiteness of the value. Yes, obviously you classify, you go for represent, everything will be done. The only difference is no definiteness here. So how you represent here? 1 to 10 marks. How many scored 1 to 10 marks? 3 students. How many scored 11 to 20? 7 students. How many scored 81 to 90? 6. How many scored 91 to 100? Only things there is no definiteness, there is a vagueness in the content, but obviously we can understand there are 6 students who are secured above 90. Okay. Actually, when you just recall your school days, this is how your teacher might have asked, right? How many got above 50? Right? How many got above 90? How many failed? Failed means what? 35 or 40 is a fail. Fail ஆனதில்ல மேம் அதனால எங்களுக்கு தெரியாது ரொம்ப நாலேஜ் தானே how many what's a fail mark 35 or 35 or okay so how many failed so immediately you know that you are 34 and you failed so especially in maths and I don't know how far they do it in accounts because I'm not an accounts student in my school days so usually what we do here is you get 35 is a pass mark and you got 34 we directly go to the teacher and you find that ma'am 1 mark ma'am 1 mark ma'am teacher one mark ma'am and you get that 1 mark so pass right that's not going to happen when you get 99 100 is centum but you are losing 1 mark over there and you go for asking this 1 mark okay definitely she will not give she or he will not give 1 mark because that 1 mark means centum okay okay so when they go for paper scrutinizing and all see there will be a separate valuation going on but anybody has secured 100 marks means there will be a second scrutiny of paper where they'll check whether the student has secured 100 marks centum is something so very peculiar right what do you mean by centum marks what do you mean by centum marks you are so very exact with the concept right even small error has not happened in that. That's what centum means, right? Okay. So this is about type 3 questions. Okay. I take over. First we'll go for mean. Then we'll go for median. Median has another name called as positional average. Okay. Positional average. Then we'll go for mode. These three will be covered under averages. Okay. These three will be covered under averages. Under dispersion, we'll be covering range, quartile deviation, mean deviation, and standard deviation. I'm not touching this concept as of now. I'm going to go with average only. What do you mean by average? When we started the heading, we were mentioning another name for average. You remember? Yes. What's another name for average? Central tendency. What do you mean by tending is moving? Tending is moving or attracted at one point. So whether it's moving or attractive, central value. Okay. Let me plot the points in x-axis and y-axis graph. I get all these points. When we say central tendency, it's attracted over the center point. So all these values will be tending to the See, central point means somewhat to the central point, not exactly the central point. If it is exactly the central point, it's called median. If it is exactly the middle value of all the values means it's median. Actually, median is about talking about the position. If I give you five values, 1, 2, 3, 4, 5, which will be the median value, exactly the middle value. If I give you six values, which will be the middle value? This will be the middle value. Am I right? I cannot say this is the middle value or this is the middle value. Somewhere in between, exactly will be the middle value, which means we are denoting the position. So, central tendency is a common word where it can be representing mean, where it can be representing median, it can be representing mode also. So, when we go for particularly talking with respect to mean, we have arithmetic mean, we have geometric mean, and we have harmonic mean. When to use which mean? You cannot use all the means every time. And they'll not ask you in the exam, you are going to use harmonic mean. They'll not ask. When you're going to use which mean means, whenever you are asked to find the average, for example, two units are given. Example, let me go for average speed. How you mention speed? What's the speed of walking? Usually the speed of walking is 12 minutes to 15 minutes for 1 kilometer. You ever checked this time? Okay. Please check your time. Usually they say that 12 minutes is the right time. Okay. Exactly 10 minutes is the right time for 1 kilometer. See, for 1 minute, you have to take 1 minute means how much seconds? 60 seconds, right? For 60 seconds, 1 minute, you have to walk 100 steps. Okay. So if you go for 10 minutes, it's 1000 steps. So your speed should be such a way that you have to walk 10 minutes, 1000 steps, 1 kilometer. You cannot say you walk slowly for 1000 steps. You take small steps and you say I have covered 1 kilometer. No. You have to, so this is the normal speed. So you just check next time how many steps you take, how many minutes you take for covering 1 kilometer. My speed is usually 12 to 15 minutes. If I feel tired, I'll go a bit slow, so I'll take 15 minutes. If I want to go, see, usually the doctors say for going brisk walk, right? So if you go for brisk walk, you have to take actually 10 minutes. But usually I won't speed up myself so much because for 1 kilometer is okay, second kilometer is okay, third kilometer I'll totally get exhausted. Okay, you should not get exhausted. You can exhaust, but you should not totally follow me. So 12 minutes I give. Okay, let me take 15 minutes. For 1 hour, how many kilometers you walk? If you are also taking 15 minutes for 1 kilometer, for one hour, how many kilometers you walk? 4 kilometers. So this is what you call as the speed, right? How you measure the speed? You know the formula for speed? Distance by time. What distance you are covering? 4 kilometers. In how many hours? 1 hour. Which means 4 kilometers per hour is your speed. So to measure speed, you need to understand two units. One unit for distance, kilometer or meter or whatever it is, and another unit for time. To understand one measurement, that is one measurement speed, you need to understand two things. Okay, here you use harmonic mean. By default, it's one thing, but with the help of two other variables only, you get this one. So here they use harmonic mean. Instead, if you are given in rate of interest or percentage, okay, so you're taken loan, and one loan is for 9%, one loan is for 10%. You're asked to find the average rate of interest. You go for finding geometric mean. If nothing is mentioned, you go for using harmonic. It's a common thing where the formula will be summation x by n here. When we use the summation x by n formula, it's no geometry. Page 21. Problem number 3. What is problem number 3 here? We are comparing arithmetic mean and geometric mean. So the question is asked like, please join here, please join here. It's quite important. The question asked here is find the average rate of return. Rate of return usually we measure by percentage, right? If they say 10%, which means 10 by 100 is the rate of return. So it's given as comparative figure. If it is given in ratios, if it is given in proportions, if it is given in percentage, we have to go for finding geometric mean. So for 3 years, they have given for year 1, year 2, and A3, the rate of return is 10% to 60% and 20%. Okay. And you go for finding harmonic mean and geometric mean. So not harmonic, geometric mean and arithmetic mean. You find by geometric mean, see, I'm not working on this problem. Okay. Because I need to discuss what is the geometric mean formula and all. I'll later discuss that one. So if you find geometric mean, the actual rate of percentages, taking the average is 28.3%. In case if you take arithmetic mean, you're getting 30%. 30% is not the right answer. You have to go for finding geometric mean. So whenever ratios or proportions or percentages, like these are the things we use it for comparison. When we say ratio, we are taking as a comparison. When we say proportion, we are taking as a comparison. Percentage, we are taking as comparison. For comparison related factors, what we do is we use geometric mean. Likewise, if we go for problem number 4, here's an airplane covering a distance of 800 miles with 4 different speeds of 100, 200, 300 and 400 miles per hour for the first, second, third and fourth quarter. So from here, you're traveling an airplane and you take it as 4 quarters. So this is quarter 1, quarter 2, quarter 3 and quarter 4. So how many miles? 800 miles. So this is 200 miles, 200 miles, 200 miles and 200 miles. For the first 200 miles, what's the speed there? 100 miles per hour. And for second, 200 miles per hour. Third, 300 miles. This is 400 miles. See, here it's given miles per hour, which means miles is a unit for distance covered and per hour is meant for time. Which means to mention the average speed, we are taking 2 other variables to compare, 2 other units to compare. In this case, you have to go for using harmonic mean, not arithmetic mean. So just think you are a pilot and you have different speeds and the instructions comes where you have to go for using average speed. What are you going to do? You cannot go and take an excuse. Sir, I did not study maths. You cannot go and take an excuse over there. So what are you going to do? You're going to find harmonic mean or arithmetic mean. You have to find harmonic mean. But everything there will be available in the dashboard. Need not worry. Even without knowing maths, you can go and sit over there. Actually, to understand the pilot, the way he travels, you have to be good in calculus. So harmonic mean, the formula if you apply, what is the average speed? Yes, please join, please join. Don't see this as a problem. For harmonic mean, if you calculate the average using harmonic mean, what is the speed you're getting? What is the average speed the airplane will be going on? 192 miles per hour. Instead, if you find by arithmetic mean, see, what's the so much difference, right? 58 miles per hour is the speed, over speed. Okay, so you may directly go and clash a mountain. The mountain will not be clashed, the airplane will be clashed. You have to understand statistics here. So kindly join. When you are using harmonic mean, when you have like 2 units representing 1 unit. When you use geometric mean, we have percentage given in ratios, given in proportions, or in something compared and provided to you means it is geometric mean. Okay. When you use arithmetic mean, nothing is given. It's a very blank data. They give some 5, 10, 100 values. They are asking you to find what is the average. Which average you're going to use here? Arithmetic mean. If they give marks number of students, which average you're going to use here? If they are giving marks at absolute values, you will use arithmetic mean. If they are giving the marks in percentages, you have to use geometric. There is a difference. Will not be provided. That will not be provided in the table. In the question itself, for the following percentage of marks, find the mean. You should not go directly and find the arithmetic mean because in the heading, what is given? Percentage of marks. Should be very careful, pa. Okay. So this is about the 3 means. So let us start with the first mean. Okay. What is first mean? First, let us cover arithmetic mean. How the formula here is, see, I told right, it'll be defining and dealing in 3 angles. One is we'll go for definition. So definition is done. What is definition means for which one arithmetic, for which one geometric. Okay. Now we'll go for formulae. Then we'll go for finding the all the means in the problem. For each and everything you're going to do this. Come here. Arithmetic mean the formula is summation x by n. Is it okay? Geometric mean formula is the difference between arithmetic and geometric mean. When we use geometric mean means when the values are independent. If I talk about ratios, proportions, or this comparison units, the values are not dependent. The values are not separately standing. We have to see. I say you get 9% interest. For 100 rupees, it's a different value. For 1000 rupees, it's a different value. Please try to understand. This 9% is not the absolute value. This 9% is what? Giving in terms of percentages. For 100 rupees, it will be totally different, right? For 100 rupees, how much? 9 rupees. For 1000 rupees, it is 90 rupees. If I give you some odd number, 699, the value will be different. See, the nature of this 9% is 9%, but for value to value, it changes. Value to value changes. So here we have to go for multiplying the values. So you multiply all the x values, x1, x2, x3. How many x's are here? In general, xn, okay, you multiply all the x values and take the nth root. If there are two values, you take the square root. If there are 5 values, you take the fifth root. If there are 10 values, you take the 10th root. Okay. Then we'll go for finding harmonic mean. Okay. Harmonic mean. Harmonic mean is ulta of arithmetic mean. What is arithmetic mean formula? Summation x by n. Here we make it ulta. You get n by not only reversing the formula, reversing the x value also. So two reversals will be there. One reversal, you take numerator and denominator ulta. Okay. Then you take summation 1 by x. This is harmonic mean. So if I have the value 3, 6, 24, 48, how you find harmonic mean? What is the number of values? N is equal to 4. 4 divided by, what's the formula? N divided by summation 1 by x. It is 3 means I'll take 1 by 3. It's 6 means I take 1 by 6. 24 means 1 by 24. 48 means 1 by 48. Is it okay? So this is how you find harmonic. Before that, for finding geometric mean, it's not always easier for us to find cubic root, fourth root, 10th root, 100th root. Okay, so the second problem we have 581 as the total count. You remember this table? See, what's the value? 581. So which means what? You have to multiply all the value and take 581th root. It's not so very easy. So what we do is we take the help of the logarithmic formula. You have studied logarithms, right? If you take log m into n, you write this as log m plus log n. You take log m power n. You take this as n log m, right? We try to apply this one over here. This is geometric mean is equal to nth root of x1, x2, xn all multiplied. Okay. Shall I write this one as like this? Please check. Yeah. Power 1 by n. Both the sides now I take log. So log of geometric mean is equal to log of this value x1, x2 all multiplied to power 1 by n. See, can you just link these two now? If the power is there, what it happens? It comes outside logarithm. Am I right? Am I right? So shall I write this step here as 1 by n log of x1, x2, x3, so on up to xn multiply. Okay, so this is nothing but log geometric mean. Now we'll try to apply this one here, this one over here. What it says, log of m into n will be log m plus log n. So if I apply over here, shall I write this as 1 by n is common, let me have it outside. So instead of mn, I have what? x1, x2 and so on. So I can write this as log x1 plus log x2 plus log x3 up to log xn. So please check, shall I write this as 1 by n summation log x? Yeah. What is summation? We take summation of all the values, add all the values. It's here plus plus plus. So I write it as summation log x. Now, what is here in the left hand side? Log geometric mean. What is there in the right hand side? 1 by n summation log x. I want geometric mean. I don't want log geometric mean. So geometric mean will be, I take anti-log. What is anti means? Reversing. Anti-log. So this is anti-log of 1 by n summation log x. So this is the formula for geometric mean. So we have two formulas. This is one direct formula. I write it as one, and this is the second formula. Yes, I repeat. See, I have chosen a very simple problem. Only thing you have to understand what you're doing inside. Okay. So what's the first problem? Type 1 problem here. We are giving four values, right? What are the four values? 3, 6, 48, 24. Okay, four values. We are going to find mean, and the first mean is arithmetic mean. What's the formula? Summation x by n. So here 3 plus 6 plus 48 plus 24 divided by n. I just want in two decimals. Yes, please don't get the value. If you have the calculator, make him calculator working. 20.25. Usually for statistics, we'll go for two decimal places. Okay. So this is 20.25. Next is geometric mean. What's the formula? Nth root of x1 into x2. Only we have four values. So we can directly take four values. So this is fourth root of. Am I right? So fourth root of 3, 6, 48, 24. Value? 3.46. You should get 12, right? 12. Or else you can go for log formula. So what is the log formula? Or what's the log formula? Geometric mean is equal to anti-log of log of 1 by n. Log of summation log x. Summation log x. Yeah, please. Anti-log of what is 1 by n? 1 by 4 log 3 plus log 6 plus log 48 plus log 24. You know how to find log values? Just turn out to the single material last page. 0 point anti-log of what is log 3? See, while we discuss indices and logarithms, I will go completely how to find log values. As of now, we managed with finding the log value directly from the table. Go for find the value of 3. 4771. So this is it's one digit. So it is 0.4771 plus log 6. 6 is 60. Had to go for 60. 7782. 7782. Okay. So this is 0.7782 plus 48 means 1 point. Go and check in 48. See, if you don't know how to find log value means you need not worry. Okay, because it will be given in the question paper. Okay, you're not going to worry how to find the log values. Please concentrate over here. While discussing logarithms, I'll teach you how to find log values. I'm not deviating myself here. So log 48, 1.6821 now. 6812, right? 6812. And log 24, 1.3802. Yeah, add all the values. Make it faster. Please join here. Anti-log of 1 by 4. 4.3167. Yeah, value. Anti-log of this one divided by this value. 1.07917592. Yeah. Anti-log value. 1.0. No, not 1.0792. You have to check. You have to check anti-log only after decimal places. This one you will not consider at all. 0792. What's the value? Check whether you're getting 11.94. 0.792. You're exactly getting 12, I think, right? Take it as 12. So this is your, see here also you got 12 and here also you're getting 12. You have to get 12, okay. If you're not getting 12, it's slightly decimal. See, I found the value as 11.94. You can find it as 11.94 in single material. Okay. So somewhat closer to 12 is fine. Okay. Shall I go for harmonic mean? Go for harmonic mean. What's the formula for harmonic mean? N by summation 1 by x. So what is n? 4. What is 1 by x summation? 1 by 3 plus 1 by 6 plus 1 by 48 plus 1 by 24. So 4 divided by 1 by 3. Can I get the value? Completely, huh? Or you get me the final decimal value. 1 by 3 plus 1 by 4. Everything put together is 324, huh? Check. Cannot get 324. 0 by 0.56. You're getting 7.11. I don't know where you're seeing this number. 4 divided by this value. Huh? Yeah, 7.11. Please check whether you're getting all these values. Median. Will not go for the formula directly. Instead, we have a common name for median called as positional average. So instead of writing median, write positional average. So under mean, we have arithmetic, geometric, and harmonic mean, right? Likewise, under positional average, see when you say positional average, its default is median only. Okay, median. First one is what? Median. When you say median, which means you're denoting the position. Is it okay? This is a set of data. First thing what you do is you arrange in order. So you can, I'll just give you time after that you can copy it. You arrange in order, usually ascending order. You can do it in ascending or descending order, but usually what we do in ascending order. This problem 3, 6, 48, 24. If you arrange it, you'll get 3, 6, 24, 48. Arrange it in order. Okay. So if this is the first position, this is the last position. Okay. So where median will lie? Exactly in the 50% half. Okay. So over here, see whether my marking is right. If you say this is your median, the normal term for representing median is M and D. Okay. Before this mark, there will be 50% of the area covered, and after this mark, 50% of the area covered, which means we'll take 1:1 ratio. This side same and that side same. 1:1 ratio. But instead of dividing into two equal halves, so median is what? Dividing into two equal halves. Okay. So what you do? Divide into two equal halves. Okay. Instead of dividing, if I divide as 4 equal quarters, which means we'll call this as quartiles, which means we divide into 4 equal parts or 4 equal quarters. So if I represent this using a line, so this is your first data, this is your last data. 4 quarter means, please check whether my marking is right. Am I right? See, not exact to the scale, right? Here, if you check to the left hand side and right hand side, shall I represent this as 1:3 ratio? See, this is not the value I am writing. This is the position I am denoting. At this position, to the left hand side. Left hand side means this is the left hand side. For us, left hand side. Okay, this is one side, and the remaining three quarters right below belongs to the right hand side. So this is 1:3 ratio. Am I right? The second marking here it is 2:2, where in ratio we write in simplified form. So this is 1:1. So this side is 50%, this side is 50%. Am I right? 50-50. This side is 25%, this side is 75%. Am I right? You go for here. This side is 75% and this side is 25% of the area. So this will be 3:1. This is what you call as quartile 1. This is what you call as quartile 2. Obviously, quartile 2 and median are the same. You agree with me? What is the median? Denoting the middle half, middle point. What is quartile 2? Yes, divided into 4 quarters, but obviously quarter 2 becomes the median one. Okay. And this is quartile 3. So usually when we talk about quartiles, we talk about two quartiles, quartile 1 and quartile 3, whereas quartile 2 is nothing but median itself. So you can just make a note of it. Okay. For median, we represent as ND. Is it okay? Actually, I'm defining. I'm not writing the formula. After this, I'll go for the formula. Shall I go for third one? Third one is, third one is, I divide into 5 equal parts. How many parts? 5 equal parts. So divide, sorry, not 5, 10 parts. 10 equal parts. Dividing 4 parts means we'll name it as quartiles, quarters. Dividing 10 parts means we'll name it as deciles. Okay. So let me have that mapping. So obviously you get this one as the first, this one as the last. Okay, we are going to divide in 10 equal parts. So roughly I can draw, this will be fifth part. 1, 2, 3, 4. 1, 2, 3, 4. Then 1, 2, not to scale, but at least I need to have some equal space here, right? Is it okay? Here. See this one, the middle one will be, for deciles will represent using D. Okay, so DI in general, I will be 1 to 9. This is D1, D2, D3, D4, D5, D6, D7, D8, D9. What is D10? The full complete is D10. Usually you will not write D10 and Q4 at all. Full complete is D10. Can you tell me the ratio for this one? This side will be 10% because you are dividing into 10 equal parts. This side is 10%, this side is 90%. For example, if you go over here, this side is 60%, this side is 40%. So what's the ratio here? Yes, please join. This is 1:9. Yeah, please join, please join. 2:8, 3:7, 4:6, 5:5. Instead, I can write it as 1:1. Yeah. Yeah, please. Obviously, this D5 is nothing but median, or you can call it as quartile. Is it okay? Shall I take over? Instead of dividing into 10 equal parts, in between we make it where we divide into 8 equal parts. Actually, I have changed the order. First, I have to go for octiles. Okay, no issues. Divide into 8 equal parts. We call this as octiles. You know octobus? 8 octiles. Usually, octo means octane, octo. It's all 8 only. Okay. So we represent using OI. I is equal to 1 to up to 7 because 8th one is the last which comprise whole 100%. So we'll take up to 7. So we'll take the line. Yes, please join. This is first one. This is the last one. This is obviously the median. I need to have 8 parts. So I cannot directly take like this. I take roughly 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7. Okay. So this is going to be, yeah, please join. This is going to be O1, O2, O3, O4, O5, O6, O7. Okay. So now tell me the ratio. Here it will be, here it will be 1/8 value. Here it will be 7/8 value. You cannot give in percentage. Here will be 1/8 of the part lying to the left hand side, 7/8 of the part lying to the right hand side. So this will be 1:7. This will be 2:7. This will be 3:7. This will be 4:4, which is nothing but 1:1. And this will be 5:3. This will be, oh, sorry. Okay, 2:6. So 2:6. Thank you, Pa. 2:6, 3:6. Yeah. 3:5. 3:5, 4:4. Obviously, this is nothing but 1:1. Then 5:3. Then 6:2 and 7:1. Instead of dividing into 8 parts, if you divide it into 100 parts, 100 equal parts. Okay. So you call this as, any idea? You call this as, yeah, please. You call this as percentiles. Usually percentage means what? 100. You call this as percentiles and you give this as PI. I is equal to 1 to I is equal to 1 to 99. You will not take the last one. Percentiles means P100 will be the last one. You will not take the last one. Last one means 100% is covered. Okay, so we take P99. So this is going to be, I cannot mark all the 99 parts here. So I'll take the middle one. The middle one will be called as P50. You agree with me? And the first one will be called as P1. You agree with me? And the last one before will be called as P99. What will be the ratio over here? 1:99. What will be the ratio is here? 1:1. And what will be the ratio here? 99:2. Definition over. Now we'll go for form. Please make a note of it. If anything you need, I'll discuss again in a different way. Probably I need the space for writing the formula. All these space. So you write in such a way that you leave some space over here for writing the formula. Okay, we'll make it as a one pager. So you need to have this heading for column, this graph, line, and we'll go for the formula now. Formula. Median. Actually, total divided by 2 will usually give the median back. But we found some accuracy error. That's why we'll not take n. Instead, we'll take n plus 1. If it is median, divide by 2. If it is quarter, divide by 4. If it is octile, divide by 8. Okay, so this median, actually median is denoting the position. So by the figure, you don't denote this as a position. So what value stands here? That value is what you call as a size. So median formula is median is equal to size of, instead of n, what you take? N plus 1. So size of n plus 1 by 2 observation. Observation is data. Okay. Second, the median, so not median, right? Quartile. Generally, we take this as Qi, where I is equal to 1 and 3. You won't take 2 because quartile 2 is nothing but median. So we won't take quartile 2. So usually it's given as quartile Qi is equal to size of, I'm going to divide by 4, which is n plus 1 by 4 observation. But what happens here is we have quartile 1 and quartile 3. So we multiply this by I. For example, third quartile. What will be the value for third quartile? I'll write it over here. Quartile 1, it will be size of how much? 1 into n plus 1 by 4th observation. Okay. If it is quartile 3, then it's going to be 3 times, right? 75%, 3 times, right? So 3 into 1, n plus 1 by 4th observation will be the answer. So we'll multiply I. So I have to draw a bracket. Probably I'll draw like this. We have to find this value, then this observation. Is it okay? Likewise, we go for deciles. Can you help me out? What would be the deciles? Di. Yes, please join. Size of I into n plus 1 by 10th observation. Is it okay? Likewise, yes, octiles. Please join. Size of I into n plus 1 by ith observation. You find this value, then go for finding the observation. You go for locating it. Then percentile pi is equal to size of I into n plus 1 by 100th observation. Is it okay? 100th observation. Yes, please make a note of it and you can try solving 3, 6, 48, 24 problem. And remember, it's not 3, 6, 28, 48, 24. You have to arrange in order. For all the positional average, whether it's median or decile or octile, whatever it is, first step is to arrange. Arranging usually in ascending order. You can arrange in descending also, but we go with the formula for ascending order. So go for arranging in ascending order, then go for finding the values. Is it okay? Yes, please. Can we join? So what's the question? First step is to arrange in order. Arrange it. So what is the value? 3, 6, 24, 48. Okay. See, for mode and mean, you need not arrange it. For median, see, median itself is called as positional average. So you need to arrange it. Okay. So 3, 6, 24, 48. Then we, with the help of formulas, we'll do all the workings. First one, median. Yeah, please join. Size of n plus 1. What is n? 4. So this is 5 plus 4 plus 1. 5 divided by tooth observation. Is it okay? This is size of, what is 5 by 2? 2.5th observation, which is size of 2.5. I can write it as 2 plus 0.5. Am I right? So the size of second observation plus size of 0.5 means after 2 it lies. Okay. So you take the size of fourth observation and the sorry, not fourth, third observation, of third observation and second observation you divide by 2. Sorry, you divide by 2 or you take 0.5. Size of 0.5 of third minus second observation. Tell me the value. What is size of second observation? I say I'm working out this one. Please join. Even though you didn't understand till here, I'll repeat it. Please join here. What is the size of second observation? This is second observation. Am I right? This is third observation. Where my 2.5 will lie? Somewhere in between over here. Am I right? That's why we are arranging in order. So what's the size of second observation? 6 plus size of 0.5 of third minus second. What is third value? 24. See, I'm not taking 3 as the value. Third 3 is denoting the position. At this position, what's the value? 24. Okay. So 24 minus 6 and here it gives 0.5. So I have to take 0.5 of this value. So this is 6 plus 0.5 of 24 minus 6, 18. So 6 plus 0.5 into 18 is 9. So this value is 15. Okay. If you go for quartile, the same thing will work out. Instead of 0.5, you'll get 0.25 over there. Okay. Can you please try? Please check whether this median is okay. If median is okay, go for quartiles. If median is not okay, I'm there to help you. Okay. Please don't go for quartile. If median is very sure, if every step is very clear for you, then you go for quartiles. If online, please, any doubts, please. We calculated all the 3 means, right? Arithmetic mean done, geometric mean done, harmonic mean done. When you go for positional average, we'll find median and all other things are named as fractiles. Okay. Fractiles will find 2 quartiles, octile 6. We are not going to find O1, O2, everything. We are going to find O6 alone. Then we'll find D7, P75. After this, we'll go for mode. So we have done with the median. What's the value? 15. Can you find Q1, Q2? So what are you going to find? Q1. So we'll find here Q1, Q3, O6, D7 and P75. Can you try? Yes, please. Median without outer. Median is 5, then you go for quartile 1. If median is 5, go for quartile. Kindly join with me. Size Q1 is Please join. See, even though you have finished, please join with me for Q1. What is Q1 by definition, by formula? Size of I into n plus 1 by fourth observation. Am I right? What is the value of I? What is the value of I? This is 1. Value of I is 1. So size of 1 into n plus, what is n value? 4. 4 plus 1 by fourth observation. Okay, go step by step working. Then size of, yes please, 1 into, what is this value? 1 into 5 by 4. What is this value? 1.25. Am I right? That is Q3. I'm working Q1 here. 1.25. So size of 1.25th observation. Till here is fine. Okay. Rohit, okay. Till here is fine. Shall I go for the next step? Size of, you split this 1.25 as 1 plus 0.25. So size of first observation plus size of, I'm not finding enough space. Let me erase this portion. Yeah. Size of 0.25 of, see where is this actually located means it's like this. Okay, it's like this. Here is Q2, here is Q1. Okay, if I post this values 3, 6, 24, 48, 3 is over here. Okay, 6 is over here. Let me have like this 3, 6, 24, 48. First observation is here. Okay, 0.25, where this 1.25 lies over here, right? This is first observation. This is second observation. So where this will lie? Over here. So which means I have taken the first observation. Now I have to take 0.25 of second minus first observation. Because it's lying in between over here. Second minus first. Because yes, please join now. So size of, yes, first observation. What is size of first observation? 3. First observation is 3. From the question I'm taking it. Okay. Plus size of 0.25 into what is second observation? 6. What is first observation? 3. So you subtract 2. So this is equal to 3 plus 0.25 of 6 minus 3 is 6 in the mind, 3 in the finger. Okay, no issues. We'll go from LKG syllabus. So 6 minus 3? 3. So this is 3 plus 0.25 of 3. 0.75. So it's 3.75. Don't copy from the board. You just check whether you can manage with the step. Without seeing the board, please try to work out Q1. I'm asking you to work out Q1 only. If you have done with Q1 by your own self now, you can go for Q3 and other. Yes, Q3, what did you do? Q3 is size of I into n plus 1 by 4. Here I will take the value 3. Am I right? Because you're taking 3. Third quartile. Observation. So this is size of, let me work out this calculation over here. 3 into 4 plus 1 by 4. Okay, what's the value? 3 into 5 by 4, what's the value? 3.75. Am I right? Okay, so this is size of 3.75th observation. Okay, so this is size of 3.75 can be taken as 3 plus 0.75. So this is size of third observation plus size of 0.75 of fourth minus third observation. So size of third observation is, see, actually in the question you will find as 3, 6, 48, 24. But first step of, before applying the formula, first step of finding the quartile is arrange in order. So your value will be now 24, 48. So this is your third observation. You should not directly take from the question. Okay, be careful of this one. So what is the size of third observation? 24 plus 0.75. Fourth observation, 48 minus 24. Is it okay? Now it's very clear, right? Then 24 plus this value, please. 0.75 of 24 of. So 0.75 of 24 is 18, I think. So plus 18. So the value here is, so this is what I do. So you can try with other one. What are the other values? 06. Try with D7 and P75. Yes, please. Over. Finished. Okay. Before finding, if you check here, this is nothing but quartile 2 or median. Am I right? This is nothing but quartile 3, or can I write this as O6? If you find the O6 value, you'll get the same 42. Do you check? If you haven't worked out O6 means you try working out and check, you get the same value because this is the position denoting Q3 or O6. Also, not only that, P75 also will be the same value. This was often asked in the exam. Probably the value of data is not given. The positional average, the O6 of the data is 42. What is quartile 3 was asked. What is quartile 3? O6 and quartile 3 is denoting the same position. So this is also 42. Likewise. So can we draw a line now? You can please join with me here. Yes. The middle point, middlemost point. Yes, please tell me. I shall write this as median, or I shall write this as quartile 2, or shall I write this as D5, or shall I write this as O4? Am I right? O4 is exact 50%, or I shall write this as P50. This one. Yes, join with me. Yeah. Q1 or D2. Actually, not D2, D2.5. Because from the 10, if you divide by 4, we'll get 2.5. So D2.5, O2, P25. Yeah, this one. Quartile 3, D 7.5. Okay. You're sure why you're getting 7.5? Any doubts? Okay. We'll do this one. Take the calculator. This is quartile 3, right? Quartile 3 means what? This is 3:1. Okay. At this point, if you take 10 divided by 4, what's the value? This is third quartile, which means 3 times of this value into 3. What you get? 7.5. That's why you're getting 7.5. Okay. Or you can write this as O6, or you can write this as P70. Okay. Your question may be, what is the value or what percentage of area lies above P0, P0? How much area lies above P0? All values. See, P0 is not about the value, it's about denoting the position. This is the position means we are going to check all the values lying above P0s, all the 100% of the value. So what's the value? All 100%. Okay. Likewise, if you go here, all that lies below P100 will be 100%. Please make a note of this line, Pa. Yes, please. Median almost done, but positional average almost done. For median, we have two formulas, Pa, to find median. One formula, what we were doing here, size of, yes, please join, size of n plus 1 by 2th observation. This is one formula. Another one formula is, see, if I have 5 values, okay, let me go like this, 1, 3, 6, 24, 48. Which will be the median? Okay, how many values are here? N is equal to 5. Apply this formula. Yes, please join. Size of n plus 1 by 2, which is 6 by 2 observation. 6 by 2th observation. So this is size of third observation, right? Able to manage size of third observation. So what's the value? What's the third observation? 6. See, if there are only few observations, directly by locating, you can find the answer. Okay. And here you find that n is odd in number. You know odd number and even number? Multiple of 2, even number. If it is not a multiple of 2, odd number. So whenever you find that n is odd, we use this formula. But in our current problem, we have 3, 6, 24 and 48. If I note this as a position, this is my middle position. Am I right? Which means lying in between second and third observation. Totally, how many observations are here? 4 observations. So shall I write this one as 4 by 2? 4 by 2th observation, right? 4 by 2 is 2. So second observation. Shall I write this as 4 by 2 plus 1th observation? What is 4 by 2? Second plus 1, which means we are talking about third observation. Yes. We take these two value and divide by 2. So we take 6, we take 24, divide by 2, which is 30 divided by 2, 15. See, we got the answer as 15, right? So when n is even, see, when n is odd, this is the formula. When n is even, see, any formula you can use it, you'll definitely get the answer. But if you are asked us to write the formula in the option A, B, C, D, they are asking which formula is applicable for which one. Then we have to go for understanding this concept. So n is even means the formula will be size of, or we can use average of n by 2 observation and n by 2 plus 1th observation. What do you mean by average? If nothing is mentioned, general average means given means we'll take arithmetic mean. So this is size of n by 2th observation plus size of n by 2 plus 1th observation divided by 2. What do you mean by average? Sum or divide by 2. Divide by. See what is the formula for arithmetic mean? Arithmetic mean summation of x value divided by n. We have only two values. One value is n by 2th observation. Another value is n by 2 plus 1th observation and you divide by 2. See, one value is this one, size of n by 2th observation. Another value is size of n by 2 plus 1th observation. You are taking only two values. So you have to divide by 2. Okay, now get me the value. What is size of n by 2th observation? Size of n by 2, which is, what is n value? Here, n is even, 4, right? So this is 4 by 2th observation. Okay, plus size of, see, please make a note, it's not n plus 1 by 2, it is n by 2 plus 1. You have to be very keen on this. Okay, it's not n plus 1 by 2, it is n by 2, then add 1. So n by 2, 4 by 2, then add 1. Okay, so this is size of, what is 4 by 2? 2, normal division, second observation, plus size of, this is 2 plus 1 observation. So this is third observation now, right? 2 plus 1 is third observation. So size of second observation, this is second observation, 6 plus third observation, 24. See, I'm getting this point. All divide by 2 because average, right? All divide by 6, 50. What is O6 formula? See, I will work out O6. You will try working on T7 and P75. What is O6? Give me the formula, direct formula. Size of, actually, what is, if it is I instead of 6, what you will write it here? If it is I, you are going to write it as I into n plus 1 by 8. Or I can write it as this way. I into n plus 1 by 8 observation. This is the formula. Now we are finding O6, which means instead of I, we will substitute 6. So this is, yes, please join. Size of, what is I value? I takes the value 6 here. So 6 into, n is 4. In my problem, n is 4 only. So 4 into 4 plus 1 divided by 8 observation. Okay. So can I get this working? 6 into 5 by 8. Can I get the value, please? 3.75. Please use the calculator and find it till you get that 3.75, right? So this is size of 3.75 observation. Now please try to visualize. This is your structure. You have 3 here, you have 6 here, you have 24 here, you have 48 here. So where this 3.75 will lie? Over here? Okay. See, this is third observation. This is fourth observation. And this is your 0.5. So 0.75 will be over here. I don't know the value. But instead what I can do? I can consider this difference and I take 0.75. So I'll take the third observation. So I write it over here. What's the third observation? Size of third observation. See, I'm splitting this as 3 and 0.75. Okay, 3 and 0.5. So size of third observation plus size of 0.75. See, I'm talking about this point where it lies between fourth observation and third observation. So I'll subtract. Okay, so this is the fourth observation minus third observation. So here, size of, what is size of third observation? It's 24 plus What? 0.75. What's the fourth observation value? 48 minus third observation? 24. Okay, so it's 24 plus 0.75 of the difference. 24. So this is 24 plus 0.75 of 24, which means you have to multiply. Okay, so 18. So 24 plus 18, which is 14. Is it okay, Vasanta? Is it okay? Mode, by definition, it is the size of highest frequency. Okay, you need to have the knowledge what you mean by highest. Highest can be only one value, right? You know this comparison? Good, better, best. High, higher, highest. Small, smaller, smallest. So when you say highest, it can be only one. What do you mean by highest frequency? Is many number of times repeated. So probably I can place a star mark and check the number of times repeated. Highest, which means many number of times to be repeated, right? That will be taken as 4. Okay. This is by definition. Actually, you cannot go or you cannot say this is the exact formula. We are in the first category, individual observation. So I'm just directly go and locate and find the answer. So second, cannot go or you cannot say by formula. Most of the time we do by location only. Location is directly we see and we find it. So in my problem, 3, 6, 48, 24. Can you tell me which is mode here? Can you tell me which is mode here? See the definition and come for the problem. No mode. Right? No mode. I am highlighting this word, highest, which means it is the only one value which is not repeating. How many times 3 is repeated? One time. Only once is there, right? How many 3s you see in the book? You see 5 3s, then change your prospects. Then wear a new one. Yes. How many times 6 is repeated? How many times 48 is repeated? In case, if I give you another 3, how many times 3 is repeated? 1 here and 1 here. So it's repeated. 3 is repeated twice. What is the size of the highest frequency? 3 is the size of the highest frequency. So 3 will be a modal value. We denote by M naught, or you call this as modal value. Okay. You call 3 as a modal value. But in my problem, I don't have another 3. I have only one 3, which means only once I have 3, only once I have 6, only once I have 48, and only one 24. There is no mode. So the mode is, we call this as mode is ill-defined. Ill-defined means what? It's not properly defined. But again, there may be some like limitations, like we cannot say exactly it's not defined. There may be some other reasons we are taking here. So what we do here is we'll go for empirical formulae. What is that called as? Empirical formulae. What is empirical formulae means? It's called as a thumb rule. What do you mean by thumb rule? You just lift your thumb. You can find 90 degrees, right? Is that exactly 90 degrees? Take the protector and check. Will not get 90 degrees. It will be 88 degrees, 89 degrees, 85 degrees. Will not get 80 degrees. So 90 degrees. When you just point out like this in your finger, your thumb up, and you point out the finger outside, you will get a line here. So I'll draw a rough figure, okay? So this is, if you hold your hand and lift your thumb. So your thumb will be here and you point out the finger outside. So this is your hand. Okay. I'm weak in my drawing. So this is your hand. Okay, this is not my hand. My hand is somewhat beautiful. This is the hand which I am drawing. Okay, so now this is your thumb. Okay, this is your pointing out finger. Pointing out finger. See, it will not be actually 90 degrees. See, you find that extra skin here. It will not be actually 90 degrees. How much it will be? Some 86 or 88 degrees only. But by locating, see, now I draw the x-axis and y-axis here. Can you imagine? X-axis, y-axis. See, you'll get plus 90 degrees. You take these two fingers and try to draw two axes, you'll get You can easily get the two lines, two axes x and y. You call this as thumb rule. Thumb rule is not the measurement, but most of the cases it will be true. Likewise, we have one relationship between the three values. What are the three values? Mean, median, and mode. With the help of these three, we can define an empirical relationship, which is bringing an equation of the three values. So the equation is mean minus mode is equal to 3 times of mean minus median. Is it okay? This is what the relationship is. Go for the left hand side. What is there on the left hand side? Please join pa. What is in the left hand side? Mean minus mode. You take this value. What is the right hand side? 3 times of mean minus median, which means you take mean minus median, multiply by 3. You'll get the same value. See, we say this empirical, which means 99.99% it will be equal. Sometimes it may not be equal. In case we are in a position that mode is ill-defined, which means what? We cannot find mode. Using this relationship, we can find the mode if you know the mean and median value. Now, what is the position here in my problem? 3, 6, 48, 24. No mode. Mode is ill-defined. So, using this relationship, I can find my mode value. Can you help me out? Yes. What is the mean value? Let me substitute the values. What is mean value? We have found already now. 15, right? Oh, 20.25. So, 20.25 minus mode, I can represent as M naught is equal to 3 times of 20.25. Median is 15, no? 15. Okay, median is 15. Okay. So, this is 3 times of, what's the value? 20.25 minus 15. 5.25. What's the value? 15.75. Yes, tell me the mean value. Sorry, modal. I'll take everything to the other side. Mode is equal to 20.25 minus 15.75 value. 5 point? 5 point, you'll not get it. 4.5, exactly. Yeah. So this is your modal value. See, using the location method, if you find it, you are getting as ill-defined. By using relationship method, by using empirical relationship, you get the value for mode as 4.5. Is it okay? So, modal value can conclude as 4.5. See, in your exam, they may be asking, using empirical relationship, you may be asking to find the mode. Else, using location method, they may be asking to find mode. Okay, sometimes they give the mean value, they give the median value, they'll be asking you to find mode, which means you have to use empirical formula. Okay, so this is mode part. So you can please make a note of it. So that's all for today. In the next class, we'll discuss with properties and other relationships.